Today you will find and verify whether or not two functions are inverses, including graphing. So an inverse relation, this is when the elements of the domain and range of a relation are flipped. So notice we have a relation R, and our domain is 1.2, 1.4, 1.6, and 1.9, and the following range is 1 and 2. Notice for the inverse of that relation, we just flip the domain and the range. 1.2 went to 1, 1 goes to 1.2. 1.4 also went to 1, now 1 goes to 1.4, and etc. An inverse function, if both the relation and its inverse are functions, then they are inverse functions. Notice in relation R, this is a function because each x only goes to one y. Each input goes to one output. However, when we flip those, this is not a function, right? So the inverse is not a function because the domain of 1 goes to 2 different y values. Okay? A one-to-one function occurs when both the function of f and its inverse f inverse are functions. And that brings us to our first problem. So notice in letter A, we are given a function, and I want to know, is this relation a function? Now, if you wanted to, you could draw a mapping diagram like we did at the very, very start of the school year. So you have an x circle and a y circle. And remember, we listed our x values in numeric order, which they're already listed in numeric order. And then our y's in numeric order. Our smallest y is 0, followed by 1, 3, then 5. So notice -2 goes to 3. So -2, I'm going to draw an arrow down to 3. -1 goes to 0. -1 goes to 1. And 2 goes to 5. So was this relation a function? And the answer to that is no, because input -1 goes to 2 different y values. And then if we look at the next part, we're going to find the inverse relation. So all we're going to do is we're going to flip our ordered pairs. So 3, -2, 0, -1, 1, -1, and 5, 2. And that's it. And then we want to know, is this inverse a function? Well, again, we can do 2 circles, and now our y's are x's, and our x's, our old x's are now our y's. So 3 went to -2, 0 went to 1, or -1, 1 went to -1, and 5 went to 2. Now, is this inverse a function? In this case it is, because each of the new x's only correspond to one y value. And is this an example of one-to-one? Remember, both the relation and its inverse have to be functions, and they aren't, so this is a no. Now I want you to take a couple minutes and try the example you tried. So hopefully for A you said yes, it is a function. Hopefully your inverse is -4, -2, 0, -1, 1, 1, and 1, 2. And the inverse is not a function, therefore it is not one-to-one. So in the next type of problem, you're going to find the domain and range of the function. You're going to find the inverse and the domain and range of the inverse relation. And then you're going to determine whether that inverse relation is a function. So the first thing we have to ask ourselves is, what is the domain of the original function? Well, if we look at the exponent, it has an exponent of 2. And if you remember, that means it's a parabola. And if I were to draw a sketch, it would look like this. And remember, this is a right shift of 4 and an up shift of 2. Okay, so our domain, remember, we can put anything we want in for x and get a y value. So we're going to do -infinity to infinity. And then the range, our smallest y value if the parabola opens up, is 2 to infinity. And then notice the next question is find the inverse. And notice the steps to finding an inverse are written off to the right. So the first thing you're going to do is you're going to change that f of x to y. And then you're going to switch the position of x and y. And now you're going to solve for y. So we're going to subtract 2. And we're going to square root both sides. Remember, when you solve by square roots, you have to have a plus or minus in your final answer. And now we add 4 to the other side. So we'll have plus or minus the square root of x minus 2 equals y. The last step is to change that y to a f inverse of x. Oh, I forgot my plus 4. Okay, so f inverse of x equals plus minus the square root of x minus 2 plus 4. Make sure that plus 4 is not under the radical. And we're going to put that up here where it says inverse. Now the next step is to find the domain. Remember, our domain and range flip for inverse. And this makes sense also because if we were to sketch its graph, this is the square root function shifted to the right 2 and up 4. And so it would look like this. And then its negative is just its reflected piece. Okay, so its domain is going to be the old range, 2 to infinity. And its range is going to be the old domain. And is this inverse a function? And the answer to that would be no. 1, the graph fails the vertical line test, and 2, there's 2 pieces. Now I want you to take a couple minutes and try the examples you try. Okay, so this g of x function, it actually graphs a line. And so its domain and range are both negative infinity to infinity. The inverse is g inverse of x is x minus 2 over 4. Its domain is negative infinity to infinity. Its range is negative infinity to infinity. And then yes, the inverse is a function. So let's talk about graphing inverses. There is a relationship between the graph of a one-to-one function f and its inverse f inverse. First of all, the graph of f inverse is a reflection of the graph of f about the line y equals x. And we can illustrate this in the following picture. So if we look at f of x equals 2x minus 4, notice we have our ordered pairs. So this is an ordered pair at 1, negative 2. We have one here at 2, 0. And we have one here at 3, 2. And we have obviously 4, 4. Okay, and then notice our inverses, that's where we flip x and y. So now we're going to graph negative 2, positive 1. And look, it just happens to be on the line of our inverse function. 0, 2, if we flip. Right? So this was negative 2, 1. This was 0, 2, and then notice we also have 2, 3, which is the sorted pair flipped, and then 4, 4, which we don't need to flip. And it's a reflection. If we were to fold our graph along that line y equals x, the lines would be on top of each other. So the next type of question we'll encounter is it says to find the inverse of relation of the function. We're going to graph that function and its inverse relation on the graph provided and determine whether the inverse relation is a function. So notice we're going to change f of x to y again. Switch the position of x and y and solve for x. So we'll add 6 and then divide by 4. Remember, you're going to change the y to an f inverse of x. So we've already found the inverse. Okay, so that's the first step. The next step, our directions say to graph the function and its inverse. So what we're going to do next is we're going to graph y equals 4x minus 6. Now, it's important to say, okay, what kind of picture does this make? Well, this makes a line. So we're going to graph our y-intercept 0, negative 6. And our slope is 4 over 1. So remember, you can go up 4 and write 1. And then we're going to graph this line. And then I don't know why this comes out all squiggly on explain everything. Y equals 4x minus 6. Okay, so what I would suggest you do next is you make an XY table based off of the function. So if we had y equals 4x minus 6, we know when x was 0, we graphed negative 6. We also graphed when x was 1, negative 2. When we graphed x was 2, y was 2. And we graphed 3, positive 6. And we also graphed 4, 10. Remember, with inverse, you're going to flip the position of x and y. So we're going to flip the xy table to get the inverse. Okay, so if we notice, we'll have negative 6, 0. We'll have negative 2, 1. We will have 2, 2. We'll have 6, 3. And we'll have 10, 4. So what we'll do now is we'll actually graph those ordered pairs and then draw our inverse. So let's see, we had 0, negative 6. Nope. Negative 6, 0. Sorry, negative 6, 0. We had negative 2, positive 1. We had 2, 2. We had 6, 3. We had 10, 4. And then we're just going to sketch a line. No, that one turned out better. And this is our inverse. And it also helps if you want to put that line y equals x in your graph to see that if the lines are indeed a mirror image. And notice they are. So we're done. That's it. Now I want you to take a minute or two and try this example you try. See if you can do it on your own. Okay, so hopefully your graph looks something like this, and the g of x is supposed to be a straight line, not squiggly. Okay. And then your inverse should be a g inverse of x is x minus 9 over negative 3, or negative 1/3 x plus 3. And the one thing we forgot to do in the previous example was state whether or not the inverse was a function. And in both cases, yes, inverse is a function. And this is also true, yes, inverse is a function. Okay, so notice we're going to do the same thing again, except now we're going to look at a different type of function. The same steps apply. So the first thing we're going to do is we are going to find the inverse of h of x. Now remember the first step, we're going to change that h of x to a y. Now we're going to flip the position of x and y. Now, to undo the square root, remember we're going to square both sides. So notice we'll have x squared equals y plus 5. And then we move the 5 over. So x squared minus 5 equals y. We change the y to an h inverse of x. And now we're ready to graph it. Okay, so remember, the first thing we're going to do is we're going to ask ourselves, okay, what kind of picture is this function going to make? So this picture is going to be a square root function. So we're going to do an xy table for h of x. And remember, we can only square root 0,149. Now, if you wanted to graph a parent function and then move it left 5, you definitely can. Or you can ask yourself, okay, what value of x gives me the square root of 0? And in this case, it is negative 5. What value of x gives me the square root of 1? And this is -4. What value of x gives you the square root of 4? That would be 1. No, -1. That would give you 2. The square root of 9, that would be an x value of 4. And we're going to graph those x and y functions, or the xy table, excuse me. So let's go over to our graph, and we are going to graph -5, 0. Okay, we are going to graph -4, 1. We are going to graph -1, 2, and we're going to graph 4, 3. Okay, so this is our h of x. And remember, to get the inverse function, we're just going to flip the position of x and y in our table. So the next step is we're going to graph our inverse by flipping our table. So the first 0, -5, 1, -4, 2, -1, and 3, 4. So now we're going to graph those ordered pairs in our function, in our same as our inverse. Okay, so we're going to graph 0, -5. We're going to graph 1, -4. We will graph 2, -1. Nope. Put it in the wrong spot. We're going to graph 2, -1, and we will graph 3, 4. And then remember, you can put that line y equals x to see if are they mirror images from one another. And in this case, they are. And remember, the final question is to determine whether or not that inverse is a function. And in this case, the inverse is a function. The end. And you have the last one to try, no way. See if you can do it. So hopefully this is the graph that you got for k of x and k inverse of x. And if we go look at our inverse work, notice that you should have gotten the inverse to be x squared plus 2. And finally, the inverse is a function. You're ready for practice. The end.